Tangents and normals to curves. So tangent to a curve and a normal to a curve are very similar, right? So we take a look at this function, f of x, any f of x, just chose this one. All right, a tangent to a curve to this f of x is going to, let's just say, touch it right here. It's going to come through, and it's going to be right there. All right, so the tangent touches this curve right there at that one spot. So this is tangent to f of x. Well, that tangent to the f of x is actually the gradient function at that point. The line of using that gradient at that x. All right? So that's the tangent. Well, the normal is perpendicular to the tangent. Okay, so this is the normal. This is the normal to the curve at that same x. The normal and the tangent are perpendicular. And back from algebra 1, when you have two lines, tangent line and a normal line, that are perpendicular, the slopes, so the slope of the normal and the slope of the tangent are negative reciprocals. All right. So the slope of the normal and the slope of the tangent are negative reciprocals. So what we're going to do is we've taken these functions, we've found the derivative, we've evaluated the derivative at the given point. Now we're going to take that one step further. We're going to take the function, we're going to derive the function, find the derivative, evaluate it at a given point, at this point x, use that x and the y and the gradient of that function to find the tangent line, because you need the slope and a point to get a line. Well, the slope is going to be the gradient at that x, all right? And then we will use the x and the y of the function. We'll get that tangent. Then we will use that same point, that x and y that we got, and the negative reciprocal of the slope of our tangent to get the slope of the normal. Well, if we take the first one, find the equation of the tangent to the curve of y is equal to 2x minus x cubed at the point where x equals 2. Well, if we do that, sorry. If we do that, we find this tangent. So what we are looking for is we're going to look for this guy right here, all right? You can graph this, you can get the idea of what this function looks like, but the very first thing that you're going to want to do is, so part one, we're going to calculate the y-coordinate at the given x-coordinate. So calculate the y-coordinate at given x. That's the first thing we want to do. So I go back up here, I plug in my x for the x here, and I get my y. Well, y is equal to 2 times, well, our x is 2, minus 2 cubed. Well, we get -4. So now what this tells us is that when I have an x of 2, my y is -4. You can get that in your calculator from your table in your graph, or you can just do it the algebraic way right here. So this is now our point that we're going to use. Well, the second thing that we do is now we find the gradient function. Or in other words, find the derivative. So if y is equal to 2x minus x cubed, then we need to find dy dx, the derivative of y with respect to x. Well, the derivative of y with respect to x is 2 minus 3x squared. All right. Well, now we're going to use this because now what we have to do is we have to find the gradient when x equals 2. So find gradient when x equals 2, because that's what we were given. We have to find the equation of the tangent when x is equal to 2. So that's our x. That's our x that we use here. Same one. Now, what I do is I come back here, and my dy dx is going to be 2 minus 2, oops, 2 minus 3, 2 squared. All right. So now, when we evaluate this, we get a value of -10. I get a gradient of -10. So my function is a slope of -10 when x is equal to 2. Well, now, this gradient is the same gradient of my tangent line. It's the same slope of my tangent line. Now I've got a slope and I've got a point. Well, if I got a slope and a point, now I can come up with the equation of the line. So now we find the equation of the tangent using the x and the y and the slope that we just found. Well, if we have a point and a slope, y minus y1 equal to n times x minus x1. Use your point slope form. Plug it in. Y minus a negative plus 4 is equal to -10 times x minus 2. Y plus 4 is equal to -10x plus 20. Y is equal to -10x plus 16. There is the equation of your tangent line. All right. Now, the second part, we're going to find the equation of the normal. Well, finding the equation of the normal, remember, if we look back at this, well, if the tangent is this guy, the normal is going to be perpendicular. So I don't have to find the equation of the tangent when I'm looking for the normal. But what I do have to find is I've got to find the slope. I've got to find the gradient of that tangent line. They're both going to use that same point. The normal uses the negative reciprocal slope of the tangent. So that's why I go through almost the same steps. So the very first thing, for this case, we're going to calculate the y-coordinate. All right. Well, if I calculate the y-coordinate, that means I plug in and I find f of 1. 2 over 1 squared plus 1. Okay. Oh, that's a -1. Sorry. Okay, so, yep. Hello.
Do you remember that? So I must ask you this.